Okay, let's do another application of the first derivative test. Again, what we're going to be able to find from the first derivative test is intervals of increasing, decreasing, relative or local maximum and minimum. How are we doing that? We're doing the sign chart method on the first derivative. So it says find intervals of increasing and decreasing of any relative extrema of the function f of x equals the quantity x squared minus 4 quantity raised to the 2/3 power. So what do we do? First step, we need to find those CVs, those critical values. How do we do that? Well, let's find the derivative. The derivative here is going to use the chain rule. Drop the power would be 2/3. Inside stays the same, so that's x squared minus 4 raised to the power minus 1, while 2/3 minus 1 would be negative 1/3. But remember, you have to multiply times the derivative of the inside. So the derivative of x squared minus 4. Well, what's the derivative of x squared minus 4? It's 2x. So I'm going to clean this up a little bit. I'm going to have f prime of x equals, well, 2 times 2x would be a 4x in the numerator. I have a 3 in the denominator, and then it was x squared minus 4 to the negative 1/3. So that's the cube root of x squared minus 4. So my derivative, I'm getting 4x all over 3 times the cube root of x squared minus 4. What do I need to do? I need to find those critical values, so I need to consider two places. When is the derivative equal to 0, and when is that derivative undefined? Well, it's a fraction, right? And a fraction is equal to 0 anytime its numerator is equal to 0. So we set 4x equal to 0, divide both sides by 4, and we get x equals 0. When is it undefined? A fraction's undefined when its denominator equals 0. So we set 3 times the cube root of x squared minus 4 equal to 0. Divide both sides by 3, you would have the cube root of x squared minus 4 equals 0. Cube both sides, you'd have x squared minus 4 equals 0. Add 4 to both sides, you'd have x squared equals 4. Square root, and remember, anytime you square root a square, you've got to remember that plus or minus, so we actually get two critical values here of a negative 2 and a 2. What do we have to do? Go back to the original function. Realize in the original function, we are taking a cube root of some value, and cube roots are defined as negative infinity to infinity. Why do I care about this? That means these critical values are in the domain of the original function, which means they are officially critical values. These are officially critical values. So all of these, 0, negative 2, and 2, are critical values. So step 2, what do we want to do? We want to do that number line. When we do that number line, we want to graph from negative infinity to infinity. Just put your bar out there with the arrows. Now we need to consider all of these points, negative 2, 0, and 2. All of those critical values. We know that the derivative at 0 is 0, and at negative 2 and 2, it is undefined. So I'm going to write that in there. That's going to be really, really important later when we figure this out, but you'll see that one in a little bit. Okay, let's think about our intervals. The first interval would be negative infinity to negative 2. The second interval would be negative 2 to 0. Third interval would be 0 to 2. And the fourth interval would be 2 to infinity. So we actually have 4 intervals we need to check here. So let's go ahead and do step 3 now. Step 3 would be do that sign chart by plugging in a value of each interval into the derivative. So I have x, and I'm plugging it in to the derivative f prime of x, which is 4x over 3 times the cube root of x squared minus 4. Let's think about a value. To the left of negative 2, I'll use negative 10. In between negative 2 and 0, I'll use negative 1. In between 0 and 2, I'll use 1. Again, I'm just randomly picking numbers. And in between 2 and infinity, I'm going to use the number 10. I try to use numbers that are very easy to plug in. 1s and 10s, positive and negative, zeros are really nice. So the easier to plug in a number, the better. Let's think about this. Negative 10. 4 times negative 10 is a negative number. 3 times the cube root of, well, negative 10 squared would be 100. 100 minus 4 is a positive number. Cube root of a positive is a positive. Times a positive is a positive. So the denominator has to be positive. A negative over a positive is negative. When I plug in negative 1, Negative 1 on top, 4 times negative 1, that's definitely a negative number. Negative 1 squared minus 4 would actually be a negative number, so the cube root of that would be negative, and a negative times a positive is negative. So we would end up with a negative over a negative, which is positive. Plug in the number 1. 4 times 1 is a positive number. 1 squared minus 4 is a negative number, so the cube root of that is negative, so 3 times that is also negative. So I have a positive over a negative, which is negative. Plug in the number 10. 4 times 10 is a positive number. 10 squared minus 4 is a positive number, so the cube root is positive, times 3 is positive, so the denominator is positive. A positive over a positive must be positive. So now that we've done our sign chart, we could come back to our number line, and we can input the results. Because the derivative was negative, again, this is the derivative. Because the derivative was negative at negative 10, it has to be negative on that entire interval. Because the derivative was positive at negative 1, it has to be positive on that entire interval. Because the derivative was negative at 1, it has to be negative on that interval. And because the derivative was positive at 10, it has to be positive on that entire interval. So now we know where the derivative is negative and positive. Remember, if you know where the derivative is negative and positive, you know what the original function is doing, and this is step 4. From negative infinity to negative 2, the derivative is negative. That means my function is decreasing. From negative 2 to 0, my derivative is positive. That means my function is increasing. Notice at negative 2, it goes from decreasing to increasing, so this must be a minimum when x equals 2. From 0 to 2, my derivative is negative. That means my function is decreasing. Again, notice it goes from positive to negative, so that means it must be a maximum at that point. From 2 to infinity, my derivative is positive, so that means my function is increasing. And again, at that point, x equals 2, I go from decreasing to increasing, so that means at x equals 2, I also have a relative minimum by the first derivative test. So the first derivative test gives me the maximums and the minimums. The only thing I have left to do is actually find the y values of these functions at that point. So number 5, I have to plug these into the original function. I'm plugging in the numbers negative 2, and I know that that's a minimum. I'm plugging in 0, and I know that that's a maximum. And I'm plugging in the number 2, and I know that that's a minimum. What am I plugging it into? I'm plugging it into the original function. So what was the original function? The original function was x squared minus 4 raised to the 2/3. I'm going to put this in my table feature because I don't want to type it in 3 times. So I hit table, I clear out what's there. I put my parentheses, I'm typing in x squared minus 4, raising it to the power of, I do a fraction and I do 2/3. Go ahead and hit enter. Start doesn't matter, step doesn't matter. Make sure you've selected ask, hit OK, and let's start typing in the numbers. When I type in negative 2, I get 0. When I type in 0, I get 2.52 approximately. And when I type in the number 2, I get the number 0. So what have I just shown? I've shown that my minimums, there's 2 of them, occur at the points negative 2, 0 and 2, 0. That my maximum has to occur at the point 0 and is approximately 2.52. Okay, that's an estimation, which is perfectly fine. I want to look, where's my function increasing? Well, it's increasing on any intervals the derivative was positive. So those were the intervals negative 2 to 0 and also 2 to infinity. Where's that function decreasing? Well, that function is decreasing anytime the derivative was negative. Well, that was the intervals negative infinity to negative 2 and also 0 to 2. So that gives me the answer to the entire question. I could determine where is this function increasing, where is this function decreasing, what are its local or relative maxes and mins. I highly, highly encourage you to go on to Desmos or go into your ebook and look at the graph of this function. You will see that we determine the exact behavior of this function, decreasing, increasing, and relative extrema, without ever looking at the graph, without using any technology. We were able to do it by hand. Hugely important.